Imagine a long time ago before modern medicine exists. What did the ancient use to treat diseases? Have you ever wondered that? In those days, our ancestors relied on nature or plant species to cure diseases. And one of the best plants with amazing properties is Carica papaya plant. Greetings to all. My name is Mohamad Fikri with Mohamad Zulkifflee. I will be presenting about my research study on phytochemical and antimicrobial efficacy of crude extract of Carica papaya leaf and seed. Carica papaya is not just a food, but able to treat diseases such as dengue or malaria. Problem raises as I wanted to understand the potential of this plant, which are various solvent can be used for extraction, and the effectiveness on bacterial strain might be different. Additionally, despite the prevalence in conventional medicine and the rise of antibiotic-resistant bacteria, the potential of Carica papaya offers opportunities to discover its phytochemical constituent and assess their potential as alternative antibiotics. So these problems actually the objective of my study, which is first to identify the best solvent for extraction, to examine phytochemical presence, and to gauge the antimicrobial activity of ethyl acetate and ethanol extracts with selected pathogens. Addressing antibiotic resistance problem is definitely crucial, or else we might return to the time where small infections can lead to death. So, this study is done to maximize the potential of herbal medicines, particularly Carica papaya. So, I did a lot of research on this plant, and I found that cowsite and friends extract phytochemical using methanolic leaf extract, and it shows positive results. Peter and Friends studies portrays antimicrobial activities for both leaf and seed when well diffusion is used as a method. In my study, I decided to use more cost-saving method, which are this diffusion method. Now that we touched on the method of my study, let's dive a little deeper. To prepare both of my sample, seed and leaf of papaya, I begin with collecting the sample, wash them with distilled water and dry it at the 40 degrees, hence grind them to powder. Then I begin to soak each sample using ethanol and ethyl acetate as a solvent at a ratio of 1 to 10. After 48 hours, I use rotary evaporator to grain crude extracts. After preparing the sample will then be run for phytochemical analysis and antimicrobial assay using this diffusion method, and statistical analysis as a method to analyze my results. My study reveals that different extracts yield different phytochemicals, but it shows that Carica papaya ethanolic leaf extracts yield the most phytochemicals compared to all. This might be due to the polarity of the solvent, where ethanol is more polar, hence able to extract more polar phytochemicals. My study found that flavonoids were absent in all of the extracts owing to the extraction method or procedure were not optimal for the detection. Terpenoids were found in all of the extracts shows that Carica papaya has a significant plant defense mechanism to protect themselves from being eaten. Alkaloids, which proven as a major phytochemicals that contributes to the antimicrobial properties, can be found in Carica papaya ethanolic leaf extracts. My antimicrobial study shows inhibition zone at different concentration against gram-positive and gram-negative bacteria. 10 microgram of ampicillin were used as positive control and DMSO were used as a negative control. It can be deduced that from here, ethanol extracts of Carica papaya leaf extract show more pronounced activity compared to other extracts. But the widest zone of inhibition is found when Carica papaya ethyl acetate leaf extracts were tested against E. coli at 100 mg per ml. You can see that the inhibition zone remained constant when observed for 72 hours. This might be due to the E. coli can get used to extract and form a barrier, making the extract less effective at stopping the growth. The Carica papaya ethyl acetate seed extracts shows absence of inhibition, indicates they are lacking in antimicrobial properties. The papaya seed, when extracted using ethanol, however, show inhibition against salmonella at 100 and 200 mg. It shows the absence of inhibition zone at 300 mg per ml due to the active compounds reach a saturation point where any additional concentration does not enhance the inhibition further. From my study, it also shows that the absence of inhibition zones for ampicillin, a positive control against E. coli and S. aureus. This is because the nature of the bacteria itself, where gram-positive S. aureus has a thick peptidoglycan layer and ability of E. coli as a gram-negative to produce ampicillinase, hence breaking down ampicillin in resisting the growth of bacteria. Moving on, 3 statistical analyses were utilized, which are Levin test, Kruskal-Wallis, and Dunn post hoc. In Levin test, the null hypothesis shows equal variances across groups, while alternative hypothesis shows variances are not equal. It reveals that a main inhibition zone against extract type and concentration, extract types and bacteria types, and concentration shows significant interaction as it has lower value than p-value 0.05, hence the rejection of the null hypothesis. In Kruskal-Wallis test, the null hypothesis would be no significant differences across different groups, while the alternative would be there is significant differences across different groups. The p-value for type of extract, concentrations, type of bacteria shows significance against inhibition zones, therefore showing enough evidence to reject the null hypothesis. However, the time shows that the p-value is higher than 0.05, hence accepting the null hypothesis. The Dunn post hoc test reveals when compared specific groups of type of extracts shows significant when compared with each other, hence the rejection of null hypothesis as the p-value is less than 0.05. Additionally, for concentration and bacteria shows significant differences as well. In conclusion, to answer the objectives of my study, Carica papaya shows antimicrobial activities against selected bacteria, with ethanolic extract of Carica papaya leaves shows more pronounced activity compared to ethyl acetate, which is attributed to the presence of phytochemicals such as tannin, saponin, alkaloids, and terpenoids. After all, I suggest that more polar solvents is utilized such as methanol, more advanced technique in phytochemical analysis such as GCMS, and minimizing the gap between sample preparation and antimicrobial study to prevent the degradation of active chemicals. And with that, I bid thank you to everyone listening. Have a good day.